Hello and welcome to TiVo, how to scale new products with a data lake on AWS and Qubole. My name is Paul Sears. I'm a partner solutions architect for Amazon Web Services, and I will be your host and moderator for today's presentation. When you joined today's webinar, you selected to join by either phone call or your computer audio. If for any reason you would like to change your audio selection, you can do so by accessing your audio pane in the control panel. From this control panel, you will also have the opportunity to submit questions to today's presenters by typing your questions into the questions panel. We will collect the questions and address as many as we can during the Q&A session at the end of today's presentation. Also, at the end of today's event is a brief survey. Please stay connected until the end of the broadcast and submit your feedback as your opinions count. Lastly, the PowerPoint presentation will be available through SlideShare along with a recording of the webinar on YouTube sent via an email that will be sent 2 to 3 days after the conclusion of the event. So keep an eye out for the follow-up email sent to the address you provided. I will be your host and moderator for today's webinar. In addition to learning about AWS, we'll also hear from Harsh Jetley, Solutions Architect with Qubole, and Ashish Mrig, Senior Manager, Data Analytics at TiVo. Today, we're going to present a brief overview of AWS and AWS Data Lake solutions. Harsh will provide an overview of Qubole solutions, and Ashish will share challenges that TiVo faced and how AWS and Qubole gave them a path to success. And finally, time permitting, we will have Q&A at the end of this webinar. Today, you will learn how to dramatically reduce management complexities of big data analytics operations in AWS. You will learn best practices for optimizing data lakes for self-service analytics that enable teams to productionalize data science and accelerate data pipelines. You will also learn about using Presto and Qubole's auto-scaling management and spot instance bidding to reduce complexity, cost, and deployment time of big data projects. And remember, please post your questions in the chat box throughout the presentation as we will review questions at the end of today's event. So let's talk about data lakes and AWS and how they drive business value. Traditionally, analytics data was stored in a large data warehouse or a large relational database system. However, these systems are expensive to implement and maintain and face significant challenges with scaling. So what is another option? Another option is to build a data lake where you can store all your data in a single large repository, and this repository becomes your source of truth for all your data and analytics. By having all your data in one place, you can discover insights that you may have missed when data is stored in different systems. So implementing a data lake is the start of a journey to becoming a data-driven business. You define your business outcomes working backwards to modernize to your modern data architecture. Along the journey, you can experiment and explore in new ways while only paying for what you actually consume. And this enables agility, allowing you to quickly adapt to new data sources and deployment of your infrastructure in minutes instead of months. When you implement a data lake as part of a modern data architecture, you gain a number of beneficial business outcomes, such as consolidation of your data into a single source of truth. This allows you to innovate for new revenues by leveraging relationships of data that you wouldn't otherwise be able to use. Another outcome could be real-time engagement with an interactive and better customer experience, and building your analytics pipeline around your data lake facilitates automation across the organization. Now that you have decided on implementing a data lake, what do you want to do with the data? Data lakes can be designed in various ways, but you need to understand your business case first and then work backwards through the analytics pipeline that you implement as a modern data architecture. The analytics pipeline allows you to experiment and scale as needed. This data lake becomes a source that lets you derive your answers and insights, regardless of the kind of data that you want to use, such as monitoring data or ERP transactions. Amazon S3 is ideal to use as a data lake and as the core of a modern data architecture. Amazon S3 is extremely durable with 11 nines of durability. This is very important when you have hundreds of terabytes or petabytes or more of data. S3 is also designed to be highly available with up to 99.99% of availability, so you can always access your data. In terms of scale, S3 is practically scaleless, and you can store as much as you need, and more importantly, you only pay for the amount of storage you are actually consuming. As mentioned previously, traditional data warehouses and relational database systems are often limited by scale. One of the primary advantages of using a data lake is that storage and compute are no longer coupled together. This allows you to scale your compute needs as appropriate for your analytics workflows, and you will learn more about this shortly. A data lake is a central component of a modern data architecture on AWS. This provides a single repository that all your relation and non-relation data can reside. A data lake is the source that will be consumed by many highly interoperable services such as ETL processes or services to query your data and tools that let you visualize your data in new ways to gain unique insights to drive your business forward. So now, Harsh from Qubole will talk about Qubole and big data activation for data-driven companies.
Thank you, Paul. Hi, good morning. I am Harsh Jaitley from Qubole. I'm a solutions architect here, and today I'm going to talk to you about how Qubole can be used to derive insights and value from the data that resides within your data lake. As you see, data teams are getting overrun today. So the needs with the data that resides in your data lake, as that increases, the number of users, the types of teams that want to interact with this data also increase. It becomes really tough to manually provision to get to that scale. And along with that, you have exploding data, you have workloads that keep on increasing, and different kinds of data types that you're working with. And this results in missed SLAs, and some people don't even get access to the data that they require. What the, sorry, the consequence of this is the activation gap. So what we see is the needs of the users have increased and the use cases have increased, but the IT budgets and the big data skills remain stagnant or flat. So what we need at this time is a way to become a data-driven organization. We have to close the activation gap and have a new approach of how we can tackle the needs of the data and of the teams that require access to these data sets. Big data can be successful with modern data lake architecture. So what are the things that you would primarily require? You should be able to scale based on use cases, and as the use cases increase and the users that want to access the data increase, they should not be blocked on scale. And and like Paul mentioned, with the by using a data lake, what you're able to do is you're able to decouple compute and storage. So what that helps you do is teams can quickly prototype and come up with new solutions. And you also need a way that you could use a, a platform where you can collaborate and different users and teams can work together and come up with more innovative solutions. And what we've seen is in 2017, about 58% of the big data projects were in the cloud. But right now we're seeing about 73% of these big data projects are running in the cloud. Their workloads are running in the cloud. And this is a typical data lake operation that we see. So below is what you see is the data lake storage, where you could have different formats of data residing in your data lake. And there would be different use cases and different people who want to access these data sets. So it could be analysts, it could be data products, data teams, your data scientists. And then they would perform different operations. So your analyst teams would use BI tools to access this data, and the formats of these data sets could be different. Your data science teams could also be using different formats, and they would use different tools to access these data sets. For example, a data science team could be using Spark for running machine learning algorithms that would do some transformations that reside on the data sets that reside in a data lake. And you could have analysts, or you could have other teams that are using Presto to run ad hoc or interactive queries with the data that resides. So all the data is available to all the teams across the organization, and different personas can access it as they want without having to worry about provisioning, without having to worry about ask for different data sets. This brings me to our first poll question. So the question is, what is the status of your big data initiative in your organization right now? Is it deployed but needs to is deployed but need to reduce cost and complexity of infrastructure? B, expanding deployments, adding more data, users or workloads? C, initial use cases are deployed but need to expand? D, have not deployed big data but are doing research on how to do it? E, no intention to deploy big data in the next 12 months. So we'll give you a quick few seconds to answer the poll questions. Thank you for submitting the poll questions. So these are the results that we see. So the maximum are expanding, 25% of the people are expanding their deployments, adding more data, users and workloads. There are about 42 people who haven't deployed big data yet, and 12% of the people have initial use cases that they're trying to expand and learn more about. Brian, can you start this? Thank you. So what we see is, for any organization that wants to become data driven, has to have a big data activation strategy. And one thing we see is, right now there are situations where the data resides in silos. It's not available to different teams. There are different replicas of data that reside, and if some team has already done work on some data sets, it's not available for other teams to reuse. So to become a to have to become a truly data driven organization and have a big data activation strategy, you need to have a way that all the data is shared and governed, and there is data access to everyone across the organization. And what we also see is, right now 10% of the data is active. It might reside in the data warehouses. There will be different data sets that are unstructured and are still not being used by organizations. So a truly activated company would have about 90% of the data sets that could be active and could be usable by different teams. Another thing we see is, in the traditional way, about for every 10 users you would have one admin person. So that's the ratio that we see across organizations. But if you want to scale and have a data driven approach, you would have to be in a situation where you have one ops or one admin person for every 200 users to run whatever use cases you want. And we've seen these ratios increase also. So you could have one to about 200 400 users. And to be in a position where you can have a self-service infrastructure, you can use all your collaborative tools, and everyone can access the data sets and use all the tools across the organization. And the focus should primarily be on the business impact and the use cases that people are trying to solve, rather than having to worry about infrastructure and the scale of infrastructure. So this is Qubole's big data activation stack. So what you see at the bottom is the cloud data lake. In this case, it would be S3. And you have the Qubole big data activation platform, which primarily shows you all the engines that you could run within this. So it could be Hive, Spark, Presto, Hadoop. And then you have different users who would be able to interact with the data sets that reside in your data lake. So you could have data scientists who are running the machine learning algorithms. You could have analysts who are running reports, doing visualizations, creating dashboards, or you could have data engineers who are actually preparing the data. They're performing the ETL activities, they're doing data ingestion, and doing other activities on the data sets. And what Qubole also provides is, which I'm going to show you soon, is how we order. Some of the features we provide is how we do workload aware order scaling, how we built in spot buying right into the engines, and how we provide all the other features. So this is a deeper look on how we perform autoscaling in Qubole. So this is a 2-hour window. The cluster starts off with about 20 nodes. There are n number of workloads that are going on, and suddenly we see an increase in the workloads. And what we are able to do is we are able to scale up to a 70. For this example, we've been able to scale up to a 72 node cluster and have a good ratio of spot and on-demand nodes. And as we see the workloads reducing and workloads completing, we are able to go down and go back down to about 10 nodes or 20 nodes, and eventually as we see the workloads increase, we are able to scale up and scale down. So this is something that we built into the Qubole platform and every engine that we use. And this is what we have seen across our customers and how they use spot instances. So for example, for Apache Hadoop, we see Apache Hadoop and Hive, we see about a 61.5% of the cluster composition is made of spot instances. For Presto, it's about 29%, and we see that it has increased quite a bit from 2017. And one of the stats that we've seen is 54% of all EC2 compute hours have used spot instances, resulting in an estimated 230 million in savings in EC2 costs. And this is how we see our customers using Qubole's workload-aware autoscaling and all the other features we have. So one thing is cluster lifecycle savings. So what we do is we are able to automatically terminate the clusters when there are no workloads that are running, and we've saved customers about $150 million on that. And we have workload-aware autoscaling, where we are able to scale up and scale down clusters. And we built the spot shopper into our engine. So what that primarily does is we are able to go to the spot market, look for instance types, and see which instance types are cheaper at that time, and build the cluster out with those instance types. So this brings us to the second poll question. How do you deploy big data today? A, on-prem, managing big data software and hardware. 2, co-location, third-party manages on-prem big data. 3, in the cloud, you manage big data and cloud infrastructure. D, cloud SaaS, multi-tenant big data service from cloud provider. E, SaaS provider, multi-tenant big data service from third party. And the results are in. So we see 46% of the people are in the cloud. You manage your big data and cloud infrastructure. 36% of the people use big data software manage their big data on-prem, and they are about 7% who are actually using cloud SaaS multi-tenant big data services and from cloud providers. That's an interesting stat. So the next thing that we want to show you, Frank, can we go to the slides, please? And this is what we see across our customers is the adoption of open source engines. So we've seen a growth of about 162% in open source engines used globally, and a growth of about 420% in Presto over the last year. And the usage of Spark is also increased to 298%. So what we also see is the number of queries that run using Presto are about 24 times more than Spark and about 6 times more than Hadoop and Hive on the engines that we support.
All right, so I think we see the first slide from TiVo. So good afternoon, everyone. My name is Ashish, and I work with the Big Data Analytics Group in TiVo in Boston. So for last year or so, we have been working extensively on a big data-driven reporting platform. So today I'm going to share some of our experiences and lessons learned on how we build a scalable reporting framework solution using AWS, Qubole, and Presto. Before we start, I want you to give you a brief context about the TiVo Analytics Group. So we are based in Boston, and we primarily deal with TV viewership data on a daily basis. We receive data from about 10 to 12 million households. We also receive demographic and location-based consumer data from various vendors, which pertains to demographic patterns, purchasing behaviors. So this essentially tells us about the households that are watching the television. And then finally, we get on a weekly basis, we get an ad listing of all the ad spots that aired on any national or local channel in the United States. So these three: the viewership, the demographic attributes, and the ad spots. Each of them on itself is a huge data set. So these three big data sets are churned through a TiVo Analytics platform, and they're made available to the reporting framework, which is called Targeted Audience Delivery, or TAD. So let me spend some time on what does this platform does. So this platform is used by our clients to build their custom targets for research. So somebody like Toyota can go in and they can define the attributes that they want to target, and then they build a custom audience, and then they can do the research based on the custom audience. Users can also view various type of TV ratings on various programs. They can discern the viewership pattern based on different dimensions that we provide on the reporting framework. The dimensions can be like network or brand or day part. And finally, they can measure the efficiency of their ad campaigns based on the target that they have created. So this platform, as I said, is called Targeted Audience Delivery, and this is used by the TV networks, ad agencies, and advertisers, and it provides them with an understanding of what and when their target audience segments are watching on the television. And this information is very valuable because this is a niche area in terms of ad targeting, and B, it allows them to tailor and optimize their TV ad campaigns, which results in huge saving for them as TV ads are extremely expensive. So I also want to touch upon some of the asks for this platform, some of the requirements. So the first thing is we provide a lot of filters and aggregation options. Which means we cannot pre-aggregate the data. So most of the aggregation is done on the live data, on the disaggregated data set. So which makes our query engine to be very challenging and very complex. Secondly, we need the results really fast because the user is obviously waiting for the reports to finish. And third and final, we don't want to pay too much money for the operational cost for managing the solution. So this is sort of a holy trinity of software development. We want to basically do everything from the disaggregated data. We want extremely high performance, and we don't want to pay too much. So with those modest goals, we decided that we will use Presto, coupled with the Qubole service on AWS infrastructure. Can we go to the next slide, please? All right, so why Presto? So as we were looking for a query engine for a solution, we wanted something that is scalable and that obviously is cost effective for us. So Presto has a bunch of advantages. Well, the first one is we have a storage compute separation. We are storing our data on S3, and as part of the reporting framework, we point our Presto query engine to the S3 and run our queries. Secondly, Presto is extremely scalable. We can easily add and remove worker nodes. Third, and this is was very important for us, we have our data living in multiple data sources. We have Hive, we have Redshift, we have MySQL, and we have flat files. So Presto can essentially query different data sources in one single query and then serve the results to the user. So this means we don't have to move the data into one place before the reports are run. So this was very valuable for us. And then fourth is we wanted obviously good performance for our analytical queries, and Presto is extremely, we found without testing that, Presto is extremely performant in scanning large amount of data. And then finally, we wanted something which is managed. So services like Qubole have out-of-the-box Presto managed service. So the next slide shows you, gives you an example of how a sample query runs on a Presto cluster. So this query essentially is going after two tables. The first table, the viewership, which is a huge fact table, lives in Hive, and the second table lives in MySQL. But the query is essentially joining them as if they're on one single database. So this obviously means that we don't have to move our data into one place. And Presto has native connectors to each of the to many underlying data sources. So through the connectors, the data is streamed and to the worker nodes, and a coordinator essentially works as a name node in the Hadoop parlance. It looks at the query and then decides on the query patterns. So as part of this presentation, we will review a couple of use cases, and I will share the lessons learned as part of those use cases. So the first lesson that I wanted to share with you is, when constructing a Presto cluster, what instance type should we use? So before I jump into the buffet of AWS instances, I want to spend some time on Presto memory and other attributes. So Presto has 3 memory pools. The system memory pool is by default assigned as 40% of the total memory. Then we have 2 memory pools which are available for the general users. The first one is the general memory pool, where all the queries by default go. And the third is the reserved memory pool, which is, as the name suggests, is reserved for the highest query, which cannot be fit into the general memory pool, that goes into the reserved memory pool. Now, what does that mean? How do we set these parameters? So there are different considerations on how do we set these things and what sort of instance type should we use. So what happens if the query, if the queries are using different memory, they have different asks from the cluster. So what we found was it is better to have multiple clusters for different workload. So if you have small interactive queries, they should go on its own cluster, or versus if you have huge ETL queries or huge reporting queries which have a big memory requirement, they should go on its own cluster. It is easier to optimize a cluster based on a consistent workload rather than trying to serve everything. So secondly, what should we use? Should we use a few big clusters or large amount of small clusters? Sorry, not cluster. Should we use a few big instance types or small amount of small and large instance types? So based on our empirical testing, we found small amount of large instance types were better than the other way around. So for example, should we use 4 nodes of R4 16x, or should we use 16 nodes of R4 4x? So the smaller size was preferable in our testing. Obviously, this can differ for other people. And then should we use compute optimized instances, or should we use memory optimized instances? And that obviously depends on your needs. Can we go to the next one? So as I said, AWS has a huge amount of instance types to choose from, and sometimes it can be confusing. This slide gives you a nomenclature of how the instances are defined in AWS. So the first letter tells you the type of the instance, whether it is memory optimized, which is R, compute optimized, which is C, or general purpose, which is T, and there are others also. Second letter tells you the generation, how old or new the instance type is. And then after the dot, we have a multiplier, which tells you how much CPU and storage multiplication does this instance provides. So can we go to the next slide? So there are literally hundreds of instances to choose from, and it can get very confusing. At least for us, we were struggling with it initially. So Dr. Bill Simmons, who is the CTO of DataZoo, which is a local ad tech company in Boston, has done this analysis. Essentially, it's called efficient frontier or Pareto front analysis. So he took two metrics. So on the y-axis, he plotted the compute efficiency measured in elastic compute unit per dollar, and on the x-axis, he plotted the memory efficiency as measured in the gigabytes of memory per dollar per hour. So essentially, he normalized all the instances in these two units, and then he plotted the units. So he plotted the instances along this x and y-axis, and quickly we found that the instances which are at the forefront are the most efficient instances and should be used. The upper right-hand corner is the utopia point, which is the most efficient combination of compute and memory, which obviously doesn't exist as we speak. One caveat that I want to point out is this analysis is assuming the on-demand pricing. Now, if you consider spot pricing, which is obviously comes with a huge discount, this numbers might change. So that's a caveat. As I said, the newer instances are most efficient, so that our decision was made easier by just considering those instances which are at the front of this plot. So the bottom two instance types, which are the R4 and C, I'm sorry, R4 and X1, are optimized for memory cluster, optimized for memory. So if your workload is highly memory intensive, then I would suggest that you should use either R4 or X1. And if your workload is compute intensive, then you should go for C5 or M4. In our case, our workload is memory intensive, but we still wanted some compute power to do some sort of analytics queries. So we went for R4, and then based on our testing, we found R4 16x large was the sort of the best fit for our workload. All right. So the next lesson learned that I want to share was how do we scale? So now that we have chosen the instance types, how many instances should we build in a cluster? So this slide, I want to give you a sample, an average Presto query, which goes against a small Presto cluster, which has one coordinator and a couple of worker nodes. So this consider this an average query, and this goes to an average Presto cluster, and it's completed in average time. So this is sort of our baseline. Now, what happens if in a reporting platform, you get 10 concurrent users who are running 10 concurrent queries? Now, your average cluster is not going to be able to service those 10 queries in the same time as it was able to service one query. So the queries will slow down as they're waiting for memory, CPU, and other resources. So what do we do? So we are using a Qubole service, which provides auto scaling. It senses the demands based on the number of processes in the queue, and it automatically increases the worker nodes based on the limit that we can configure in our cluster definition. So it will auto scale up to the limit that we have provided in the cluster. Now, the 10 queries are being serviced by 4 or more nodes, and then they're now running at a good clip. So far so good. So now what happens if the demand again dips? Now we are back to one user, one query. So now your 4-node cluster is overkill because one query can obviously be serviced by 2 nodes. So the Qubole service again does a downscaling based on the demand. It will take down 2 worker nodes, and your one query is now back to your regular cluster, so that we don't have to obviously pay for the extra nodes in the cluster. So now what happens if you have a sort of an average query? You have a huge query which is, let's say, scanning 6 months of data and requires a lot of memory. So the Qubole service again senses that there is a huge demand on the worker. The workers are pegged at 100% of CPU and memory. So it will auto scale, and it will add, again, it will add more worker nodes based on your limit. But the problem is the upscaling will work only for the new queries. The query that is already running will not see the benefits in terms of the new workers that have been added. So the net result will be the query, even though you have upscaled, the query is still using 2 worker nodes, and whatever additional worker nodes you added are sitting idle. So the lesson here is that if you have multiple or concurrent queries, then auto scaling works beautifully. If you have a different workload query, then auto scaling is not an option. It's not a good option. Maybe using a different cluster, sending that query to a different cluster is a better option. So that's how we sort of figured out auto scaling part, and we ended up having 3 or 4 clusters for our workload: one for ETL, one for interactive queries, one for huge queries, and one cluster was always on for all the miscellaneous work that coming from the users. So I want to summarize the results and the lessons learned that we discussed so far. So number one is elastic scaling. So that was our main consideration. We don't want to pay for the infrastructure if you're not using it. So using Qubole service, we are spinning the nodes up and down, and we are obviously then paying for the service as we use. This was a huge deal for us. Secondly, we are using specialized clusters. We are not using one size fit all. We are following the old adage of horses for courses. So every workload will have its own cluster, which is optimized and configured for that workload. And then finally, we have a storage and compute separation. We don't want to be tied up in a closed system or an appliance where the system is always up 24/7. So we wanted to have an open storage solution, and which was provided by AWS S3. So the benefit of this is Now I can obviously I'm using Presto, but I can also point my Spark. I can point Spectrum. I can point Hive. There are a number of solutions available in the market where I can use to point to the same data without actually copying the data to different places. So this increases our scalability and the data availability. All right, so this slide gives you some of the links on AWS and Qubole in case you're interested in trying the solution. And I think we are at the end of the presentation from TiVo. So I think we can open the meeting for Q&A.
Hi, yes. Hi, thank you, Ashish, and thank you, Harsh, as well. We just a reminder before we get started in Q&A, the presentation as well as recording of the webinar will be emailed out to you. Links to those the content will be emailed out to you in a couple days. So please look for a follow-up email about this, and that will get you the access to the slides available on the SlideShare as well as the webinar on YouTube. We have a few questions that have been submitted. There's one I want to go ahead and answer for the general audience, and that was we had a lot of discussions around what was spot instances, and the question was what are spot instances? And so spot instances are spare EC2 capacity. And it's offered at a significantly lower price than the standard on-demand pricing. So if you were to launch an EC2 instance, that would be normally launched under what we call on-demand pricing, which is the standard pricing. As a spare capacity may be available depending on instance type and quantity, there are times where those are made available to what we call a spot market, and they're offered at a much lower price. The caveat is that these instances can be reclaimed back and be assigned to as demand needs, and so spot instances aren't guaranteed to be persistent for any period of time. You will have a 2-minute warning when that instance will be terminated to give you opportunity for your whatever you're doing on your instance to be cleaned up and saved if you need to and such. But that is the advantage, is that you get a significantly less expensive cost for the using instances, but at the same time you have a risk of possibly losing the availability of those instances if they need to be reclaimed. You can learn more about this at aws.amazon.com/ec2/spot. Okay, so we're having a few questions for Qubole and for TiVo. So first for Qubole, one question that came in was, what kind of engines do people use for different use cases, and can you provide some examples of those use cases, engine types and use cases?
Sure.
This would be for Harsh.
Thanks, Paul. Yeah, Harsha. Thanks, Paul. That's an interesting question. So over the years, we've seen the adoption of multiple engines being used across organizations increase quite a bit. So we see, like the slides pointed out, we see people using a lot of Presto. There is a lot of Spark and Hive and Hadoop in the mix. So if you talk about specific use cases, what patterns we see with customers is that for interactive workloads or interactive queries, we see a lot of customers use Presto. Ashish had also shown that they use Presto for quite a few of their interactive queries. And some interesting use cases that we see with Spark is machine learning workloads, ETL workloads. So if people want to do some data wrangling, want to test and train their algorithms, they do that using the Spark MLlib packages within Qubole. And it depends. So use cases it could be ETL workloads. ETL workloads could be Hive, Hadoop, Spark. Interactive queries we've seen a lot of adoption on Presto, and for machine learning, we've seen a lot of people go to Spark in this case.
Great. Okay, thank you. Actually, I have a number of questions around using Spark and Hive and queries and such. So one question came in around, how do you send queries to different clusters in Qubole?
Right. So there are various ways. So one is the Qubole user interface. So you could, we have a integrated workbench. So using that workbench, you could choose what query you want to compose and which cluster you want to run it against. That's one way. The other way would be we have a REST API that is exposed. So you could use a REST API and submit the query to a particular cluster. The interesting thing over here is that the clusters can be down when you submit the query. And as soon as a query or a workload is submitted, it automatically starts the cluster, runs the workload, and eventually terminates the cluster also. So, and we've seen customers who use other BI interfaces. So you could use Looker, Tableau, or any other BI interface and connect to Qubole too. So with our JDBC drivers. So we have JDBC, ODBC drivers. So those are a few options of ways people can connect to Qubole and eventually run workloads on clusters.
Okay, we'll go ahead and stay on the Qubole theme right now. Some more questions coming around this. So another one is, do you have to do anything for any tuning of memory on master nodes as opposed to worker nodes? And if so, do you need to have instance types that work better as masters?
Right. That's a good question. So we have recommendations. So what we've done internally is we've been able to look at instance types, and we have recommended settings that we have for instance types. And we've also built for especially for Spark, we built this tool called Spark Lens. So primarily tells you how the workloads are running and if you need to tune something. And again, a lot of statistics are available, and most of we have recommendations for certain instance types for Presto and what instance types to use for Spark. So those are tuned, and for master and worker they're tuned differently too. Yes.
Great. Okay, I'll actually ask a question now for Ashish for TiVo. So we appreciate you sharing the TiVo story. So what is next for TiVo? Will you be incorporating say machine learning into the product?
Yeah, hi. Thanks, Paul. Yes, that's a good question. So on our roadmap, we have a use case for TV viewership predictive analytics. Basically, that involves forecasting the viewership patterns for the next quarter and for different target and audience segments. This is extremely useful for our clients, for our advertisers, because the ad buys that happens, it happens a quarter or two before the actual TV broadcast. So those upfronts are very important, and the advertisers want to see the viewership patterns for the next quarter. So we are running some proof of concept, some experimentation with the machine learning algorithms to do exactly that. So I would say stay tuned for more information.
Okay, and actually, I'm gonna go and follow up this question with Qubole. So, can you talk about how Qubole can be used for machine learning?
Right.
That'd be for
So
Harsh.
right. Thanks, Paul. So a lot of ways you can interface with Qubole for machine learning. One is we have Zeppelin notebooks built into Qubole. So what would primarily happen is you could install the packages that you want, your machine learning packages on the cluster. As the cluster comes up, those packages are available. And then you could use a notebook interface to do your data wrangling, do your testing and validation of your training, testing and validation of your models. And this could be done for different models. So if you want to build a model of your own, you could do that too. Or if you want to use existing models, you could do that using Qubole.
Great. So follow on with some more Qubole questions. There seems to be a lot of interest in the product. On Qubole, can you write SQL, Python, Scala, etc.?
Yes. Yes. So like I mentioned, we have the workbench. So the workbench primarily gives you a way to execute your queries. So you could have a Presto query, and if you use Spark, you could have your Python, Scala, and you could also submit jars, or you could write Spark SQL in this case. So you could submit any of those queries using our workbench or the REST API.
Great. Okay. That makes a lot of sense. So how about let's look at maybe some dashboarding. How do you build dashboard in Qubole? Does it have something like Tableau that talks to Qubole? How do you get that type of data visualizations available?
Right. So there are a few ways. So one is we have the notebook interface. So the notebook can be converted into dashboards. So for example, we have visualizations that are centered in the notebooks. And with that, you can have dashboards that are refreshed on a cycle. So you could have a dashboard that is refreshed every 1 hour, and that dashboard could be used. So visualization in this case could be using Matplotlib, Plotly, or any other visualization tool that you want to use. The other aspect is how do we interface with the BI tools? So we have JDBC and ODBC connectors. So you could use those to interface with any of the BI tools like Tableau or Looker.
Okay, so that's actually very interesting how you can interface with Tableau, Looker, and such. So let's take it back to TiVo, and maybe you can discuss some of what you during your lessons learned, some of the best practices that you discovered when maybe moving SQL code from data warehouse into Presto. Did you have any challenges you faced when doing that, or some practices you may have derived from those lessons learned?
Yeah, absolutely, Paul. So every database, every system is different, so there are obviously some nuances. And Presto, I would say, is a query engine, and it's maturing, but it's not as mature as some of the other ones. That being said, there are some nuances that we have to account for. So number one is when you're doing a multi-table join, the biggest table should be the first table in the join. And this is because the default join setting is broadcast. So Presto tries to broadcast the right-hand table. So if you have left table as the biggest table, then that join works a lot better. Secondly, Presto is a columnar engine. So you should only select those columns that you need, because otherwise we are doing unnecessary data scans. Third, we found that sometimes the row number function is slow, so we had to do some workaround using rank or something similar. And fourth, if you're trying to access from a partitioned table, then the partition column in the query, which is used for the partition pruning, should have the explicit values. Now, if you try to deduce that value using a subquery or something else, the Presto optimizer doesn't know the values upfront. Then it will try to do a full table scan, so which obviously is hugely expensive. So explicit values in partition key are very important. And then finally, I would say when you're doing a group by, the columns with the high cardinality should come first when you're writing the query, and that we have found has big performance gains.
Okay, great. So I've gone through most of the questions that have been submitted here, and I think we're about out of time for this webinar. I do want to go ahead and emphasize to everybody to please stay connected to the webinar when it ends, to complete a brief survey about the at the conclusion. And we do look forward to supporting you in current and future projects. We do apologize for the technical difficulties we were having with the presentation itself. And as another reminder, the links to the deck will be available through SlideShare, as well as the recording of the webinar on YouTube, and they will be distributed to you via a follow-up email that you'll receive 2 to 3 days later. So again, please remain connected and complete the brief survey at the end of this webinar. Your feedback is very important to us. Thank you.